In this lesson, we are going to solve quadratics using the quadratic formula. And the quadratic formula is outstanding. It's my second favorite way. My first favorite way is to factor because I find factoring to be quick and easy. But as we said before, factoring doesn't always work. And the quadratic formula works every single time, which is why it's so great. So in the quadratic formula, there's a couple of things we need to understand. First, we need to make sure that our quadratic equation is in standard form, which means we need to make sure that everything is on one side and 0 is on the other side, just as we would if we tried to factor. So for instance, in this question, I would subtract that 8x over, and I would subtract the 90, and that would leave me with 2x squared minus 8x minus 90 equals 0. That's what we want, just as if we were going to factor. Step 2 is we're going to use the a, b, and c values into the quadratic formula. So this is the quadratic formula. And this is great because all we're going to do is plug in our b's and our a's and our c's, and then we're going to simplify, and that's going to give us our 2 answers. Notice 2 because of that plus or minus. So let's do this one together. X equals the opposite of b. So let's go ahead and write my a, b, and c value. My a value is positive 2. My b value is negative 8, and my c value is negative 90. So I'm just looking at the 3 parts. They do have to be in that order. The a has to be the one with the x squared, the b has to be the one with the x, etc. So if I'm doing the opposite of b, the opposite of negative 8 is positive 8, plus or minus the square root of negative 8 squared minus 4 times a times c all over 2a. So a is 2. And then I'm simply going to do whatever I can to simplify the top and the bottom, the numerator and denominator. 8 squared is 64. 4 times 2 times negative 90 is negative 720. But I have minus out here, so it's minus a negative 720, which is plus 720. And my denominator is 2 times 2, which is 4. Then I'm going to add those 2 values on the inside, and I'm going to write it here just for the sake of space. So I have 8 plus or minus, and I have the square root of 784 over 4. And then I'm going to try to take the square root of 784. The square root of 784 is 28, so I have 8 plus or minus 28 over 4. We all know there's going to be 2 solutions, so I'm going to write x equals 8 plus 28 over 4 and reduce that. So 8 plus 28 is 36, divided by 4 is 9. And then I'm going to take 8 minus 28 divided by 4, which would give me negative 5. So my 2 solutions would be 9 and negative 5. Whenever I get some nice whole numbers like that, that means at the beginning I could have factored and gotten the correct answer that way as well. Let's try this one. Same steps. Everything's in standard form already, which is great. So it's already there. Now I'm going to use my quadratic formula, which is right up here for you. If you have a chance, Google songs for the quadratic formula because there's one for Pop Goes the Weasel that's very catchy. I'm not going to sing it for you, but it's very catchy. There's also one that's very funny that I might send a link out for you because it's hilarious. But I digress. In this case, I have a is 3, b is negative 4, and c is 2. So those are the values that I'm going to use as I solve this quadratic equation. So x equals the opposite of b, which is negative 4, so that's positive 4, plus or minus the square root of negative 4 squared minus 4 times a times c all over 2a. And then we're going to simplify anything we can. So 4 plus or minus, on the inside I have 16. 4 times 3 is 12, times 2 is 24, so 16 minus 24 over 6. 16 minus 24 is negative 8, so I have 4 plus or minus the square root of negative 8 over 6. I know that 8 is not a perfect square, but that 8, obviously I've got a negative on the inside, and I don't love that. I also know that I could break negative 8 into the square root of negative 1, the square root of 4, and the square root of 2, which means I'll have an I, and I'll have a 2, and I'll have this 2 still in the radical. So I have 4 plus or minus 2i radical 2 over 6. And then, of course, I should be able to simplify this. Whenever I simplify it, remember that radical, the stuff in the radical stays in the radical. So the radicand stays alone. I can reduce these values. It doesn't matter that there's an I on this one. I can still reduce everything by 2. So I'm going to turn 4 into 2. 2 turns into 1, so it'll just be 1i or I radical 2. And then 6 divided by 2 is 3. So I would just probably leave my answer exactly like that. If they wanted 2 answers, I would write it as 2 plus I radical 2 over 3 and 2 minus I radical 2 over 3 would be my 2x values. We didn't talk about graphing in this course, but if we were to graph this, that would mean that these don't actually touch the x-axis. Here's another for us to try. So again, A would be 4, B would be negative 20, and C would be 25. I'm going to now just plug and chug. So opposite of B would be positive 20, plus or minus the square root. B squared would be negative 20 squared, which would be 400, minus 4 times 25, which would be 400. And the denominator would be 2a, so 2 times 4 is 8. So notice I showed a little bit less work on this time around, and that's okay. Now some people might freak out a little bit on this one because, as we can see, the radicand is 400 minus 400, which is 0. So what is the square root of 0? It is 0. So it's 20 plus 0 divided by 8 and 20 minus 0 divided by 8. That means we're just going to have one solution because it's going to be the same answer both times. So my answer is 20 divided by 8, which of course would be 5 divided by 2, 5 halves. Now, in terms of what that would look like on a graph, that would mean that at 5 halves, which is halfway between 2 and 3, that we would have a parabola that would come down and touch at 5 halves. Sorry, that's a bad parabola, but it would touch at 5 halves and then turn around and go the other direction. Some books might call that a multiplicity of 2, because that would be technically 2 solutions at that point. Here's another for us to try. Again, we have A is 2, B is negative 1, C is 2, and we're just plugging into our formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times 2, which is 16, all over 2a, which is 4. My numerator is 1 minus 16, which would be the square root of negative 15 over 4. And what students often do is they just leave it like this because 15 can't be reduced. It breaks into 5 and 3, and neither are perfect squares. However, I don't ever want to leave a negative on the inside of a radical, so I would write that as I radical 15 over 4. And again, if I had to write that as 2 solutions, it would be 1 plus I radical 15 over 4 and 1 minus I radical 15 over 4. Here's one for you to try. So try this first, then press play to check your work. For this particular question, if you'll notice, I don't have it in standard form yet because 4 is on the wrong side. So I do have to subtract that 4 before I can find my a, b, or c values. So 6x squared minus 5x minus 4 equals 0. Now, a is 6, b is negative 5, c is negative 4. So my values here, the opposite of b would be positive 5, plus or minus the square root of negative 5 squared, which is 25. Remember, whenever you square a number, that number will be positive, unless you're dealing with an I value. Minus 4 times a times c, so 4 times 6 times negative 4, so minus negative 96. all over 2a, which would be 12. I'm going to go ahead and ching here in the middle to combine those values together. That gives me, on the inside, I get 121. And the square root of 121 is 11. And this one's nice and neat, no radicals left over, and so now I can just find my two values. So I would never leave my answer like this. I would if there were radicals, if there were things I couldn't reduce, but in this case I would actually find the two solutions, which would be 5 plus 11 divided by 12, or 16 divided by 12. Reducing that by 4 would be 4/3. The other answer would be 5 minus 11 over 12, which would be -6 over 12, or -1/2. So my two solutions would be 4/3 and -1/2.